So let's take a look at some of the questions that you guys had for Chapter 7 on territoriality and migration. So the first question asks about the ideal free distribution, and is it possible for animals to settle on territories that are of a lesser quality but with fewer members for competition? And that's exactly what the ideal free distribution says. It says that you're going to have different, let's say, quality of territories, and yes, they'll settle on the ones that are higher ranking first, but part of that ranking is going to depend on how many individuals are using it. So you could have 2 individuals on a very high ranking habitat, because even though there's 2 of them on there, each one is still getting maybe more resource than if they were on a slightly lower quality resource. So it is going to have to do with not just the physical nature of that habitat, but also by who's using it. So the level of competition definitely gets factored in here. And that's why you will see, again, sometimes multiple individuals on a very high quality territory. This question is asking about density-dependent habitat selection. And if you go back and look at what they say, they talk about how it's essentially looking at animals selecting their habitat based on the productivity of the habitat, so the quality of that particular habitat, but then also the intensity of the interspecific competition, which, remember, is within species. And this question is asking, well, do we not consider interspecific competition as well? And I would say that in most cases, when they're looking at this particular kind of model in territoriality, that interspecific competition kind of goes more into the overall habitat productivity piece of it, because what they're trying to do is they're trying to specifically model what do individuals do in selecting a habitat when they're faced with decisions that other individuals of the same species are making. And so the reason why they're focusing here on that intraspecific piece is, again, kind of going a little bit back to game theory and the hawk-dove and some of those kinds of things. We're looking at interactions within species, because specifically territoriality looks at defending a resource from conspecifics. And so it doesn't, you don't talk about territoriality when you're talking about other species. You don't say, it's behaving territorial to this other species that's coming in. We just don't use that term with it. So I think that's why they're focusing primarily on intraspecific competition here. But it doesn't mean that interspecific would not be important, because interspecific competition is going to help define the quality of that resource. So it's a good question, because I think they both come into play. They're just viewing them in a slightly different framework, and so they're classifying them slightly differently. This is asking about the predictions under the ideal free distribution, and the idea that individuals are going to put themselves on habitats in such a way that they're maximizing their reproductive success. So again, if I am looking at 2 different habitats to settle on, and one already has an individual on there, but it's a really, really quality territory, and then another one doesn't have one, but it's a slightly lower, I'm going to pick the one that's going to maximize my reproductive success. And so that's the idea of the ideal free distribution theory. This is asking how that kind of relates back to carrying capacity. So a couple of things. Carrying capacity is looking at having a full environment. And so if you're looking at after you fill up this habitat, so under ideal free distribution, if you say, okay, I've got to put 100 individuals in here, this is my carrying capacity, I'm going to fill it all up. I suppose, yes, carrying capacity would be reflected in that, and so it kind of is consistent with carrying capacity in that way. However, I don't think the reproductive success that we have that's mentioned on there is actually synonymous to carrying capacity. Reproductive success is a little bit more like, if you want to think back to ecology, when you're looking at population growth curves, remember you have R and K. So R is looking at how fast the population is growing, and K is looking at that population size that it stabilizes and there's no actual growth. Well, technically, R is going to be that growth. Reproductive success is really more a measure of how fast that population is growing. So it's really a measure of R rather than K. So it's kind of similar, but it does apply, but I wouldn't say that maximizing reproductive success is going to happen at carrying capacity, because remember, at carrying capacity, births and deaths are equal, and so in most cases you're not really achieving a maximum reproductive success when you're there. You're achieving maximum reproductive success when you're in that really heavy, growth phase of the population growth curve. This question is asking about how do females know the size of a male's territory. It says that a male's territory is where he has access to all the resources, but other males could cross through that. There have been quite a few studies that have shown that females, when they do choose males based on territory, it's a fairly long-term decision. They don't just come in and decide really quickly. They probably pass through territories, they visit them frequently, and so they're really assessing a lot over time. And I think if you were to watch these territories over time, it would be a little bit more evident who's the owner of the territory and who's the individuals who are just passing through. And it would also give them a better way to assess like the quality of a territory by being able to see it over time. This question is asking about this graph and with the red knots, the ideal free distribution graph, and what are the different squares representing. So over here, this is basically looking at a hypothetical model where the resources distributed very evenly. So the red squares are looking at like a medium distribution of food. The white ones are, there's hardly any food there, and then the black dots, there's a whole bunch of food. So here everything's pretty evenly distributed. Over here what happens is you've got some areas that have very little food, some have a little bit, and then some have a whole bunch. So it's kind of more patchy, more splotchy distribution. And so they're looking at sort of two different models. How would you expect the animals to distribute themselves in this particular habitat if things were evenly distributed? So they did a model based on that. If we were to go out and measure where they're sitting, we would expect them to be in these where the blue ones are, and then the actuals are where the red ones are. And so you can see there's a lot of places where they don't match up very well. Here at 4, there at 6 and 7, the predicted and the actual don't fit very well. So that model doesn't really fit very well. Over here, it's saying certainly we would expect a lot more on these darker areas. And then, of course, not very many on some of these lighter areas, and then kind of intermediate on the red areas. And so that's what this model is looking at. So it went through, again, the red knot habitat and said, here's how many I would expect to be in these different physical locations, and then this is where they are. And you can see this model matches a lot better than this one did. There were a few areas where this was a little underestimated and overestimated, but a lot better fit than we had with the even distribution model. This question is asking, kind of similar to the one we had a few minutes ago, about how do competitors know that the other male is the owner of the territory, and what if two random males are crossing through the territory of a separate male. Territoriality is something that develops over time. You definitely see different territorial displays in many cases in a resident male as opposed to an intruder male. I suppose there could be a little bit of confusion if a couple of males got into a fight on another male's territory, that an onlooker might think of that as, oh, well, one of those is the territory owner. But again, a lot of these are fairly long-term interactions. So it's not something that happens just once. Neighboring territories are witnessing these kind of interactions a lot. Other animals are watching them. So I don't think that there's a whole lot of confusion as to who the owner and who the intruder is. Two questions are looking at the chimp patrolling behavior. With the costs and benefits of defending a territory for chimps, it makes sense why they defend with regards to benefits. But why do we also often see this behavior in domesticated animals where the costs seem to outweigh the benefits? A lot of times what you're going to see in domesticated animals, like your dog becoming very territorial over its yard, is that selection really hasn't gotten rid of those particular traits. So if those traits were inherent in the species from which the domesticated animals came, there's really nothing acting to eliminate the trait. So even though there might be not be selection still acting to enforce the trait, there's also not selection really there to try to eliminate the trait. So if being territorial as a domesticated animal made you have lower fitness, then I could see that that type of behavior would be currently being selected against in domesticated animals. But because it's not really selected against, it's probably something that's just there as a sort of an artifact, a historical artifact. I would like to know more information on male chimps and patrolling their territory. They can attack and kill members of other groups, but will they also attack members of their own group? say if one displays weak behavior, they will sometimes attack members of their own group. There have been some situations where males have not been very faithful, let's say, to the group and have been driven out. That does happen. There's quite a bit of what they call chimp politics. Franz de Waal's book on chimp politics talks about this kind of thing a lot, where males will form alliances, and let's say two weaker males might be able to take on a stronger male, and they can also move up in the group. And so there's a lot that goes on. There's a lot of social dynamics that go on in these types of animals and their territoriality. So I do think that you probably do have occasionally, particularly if a member within the group is not pulling their weight, if they've done something against the group, that they will be attacked. So it does happen. Obviously, it doesn't happen as often as between group attacks, because those coalitions of males that are patrolling that are definitely much more inclined to attack males from another troop. This question asks, can you explain the costs and benefits of territoriality and resource holding power? Domesticated territoriality in action. Okay. Enough domesticated territoriality. Stop it. So some of the costs, of course, they spend time defending. They spend quite a bit of time, and that's time away from doing other things like collecting food and mating, etc. They risk injury. They also, males that defend territories often have elevated testosterone levels, and those have been associated with a lot of different things. As it says here, reduced parental care, immunity, increased activity level, which then can also have negative consequences to their overall fitness sometimes. The benefits, of course, are you get more food because you're expanding the size of the area you're defending. And remember, the sort of our definition of a territory is you have exclusive use of that particular area. The benefit is you add to your resource base, whether that's food or it might be water or nest sites or whatever. The biggest benefit is if you have a larger territory, it should result in higher reproductive success. The idea of resource holding power really looks at the cost effectiveness of an individual who's able to hold on to a resource. So that's why a lot of times they think that residents might have a little bit of an advantage in territoriality as opposed to intruders, because they're more familiar with that area. They have a better idea of the actual value of that area. They know where all the food sources are. They know where predators might tend to encroach on that. So the benefit to the owner is actually a little bit higher than the benefit to the intruder who's unfamiliar with the area. And that slight asymmetry there makes it so that if we shift that cost-benefit ratio a little bit, that's probably one of the reasons why the resident tends to win more often, is because they actually have, even though it looks like the benefit should be the same for both members, it's not, because the familiarity of the owner gives it a slight more benefit to the owner. This question is asking about the data from Yarrow's lizards. How does this graph relate to whether or not they defend their territories in breeding and non-breeding seasons? So this is a good question because it doesn't really explicitly say it very well. So let's look at what the data are showing here first. So the implants are the ones that have been given testosterone implants compared to the control. And this is just looking at the percentage of the lizards that are active, of those who've been implanted in the blue line and those who have not, the control line. Lizards who receive testosterone implants are much more active all day long. So throughout the day, there's one part of the day where they're almost the same, but if you were to add all this up over the course of the day, they're much more active. So they're spending more energy because they're more active. Then what we're seeing over here is the survivorship. So they're all getting, control is looking at basically this group, and then the green and the yellow here are looking at the testosterone implant, whether or not they're supplemented with their food or not. So this is the no supplement, and then this is the supplement. So if you take an animal and you give it testosterone, but then you also give it more resources, so you supplement its food, it can offset that cost, right? So there's a cost of being more active over here with the testosterone implant. And if we supplement that, then the animal does really well, even better than the control. But if we don't, if we just crank up that testosterone and we don't have any supplemental food supply for that animal, it is drastically reducing its survivorship. So this is trying to show that there's a significant cost to this territoriality, because we do know that it's associated with elevated testosterone levels. They're much more active, they're burning a lot more energy, and they're less likely to survive under normal conditions of no supplementation. They went on to say from there is that means that if there is this high cost, then what we ought to see is that animals in the non-breeding season should not defend territories. If your whole reason for territoriality is to attract a female and to provide for offspring, whatever, during breeding season, then when there's the non-breeding season, what is the benefit? The benefit's gone at that point. So when the benefit is gone, then we should not pay that cost. And so that's one of the things you find in a lot of animals where there is this high cost and there's really no benefit to trying to maintain a territory throughout the non-breeding season. So some animals might hang on to a territory throughout the non-breeding season so they have it again during the next breeding season. But in many other cases, that's not going to happen. And that's the case with the Aros lizards. So they're not going to defend during the non-breeding season. This question is asking about territoriality in redstarts. And so it's asking about this graph, which is a little confusing. It's asking about the arrows down here. If you look across this x-axis, what you're seeing is on the far left, we have what would be two different variables. The winter habitat is wet, and animals that are in that particular habitat also tend to have usually early departure dates. So when they get ready to go back from wintering to their sort of spring habitat for mating purposes, they leave earlier. So if you're in this kind of a habitat where it's wet, you also leave earlier. Over here we have the scrub habitat is very dry, and individuals that overwinter in a scrub habitat also tend to leave later. So you can see both of those things then really affect the number of young an individual can have. If they winter in a good wet environment and can leave early and get to that breeding grounds earlier, they do really well. If they are in a dry habitat, which means they have to essentially stay there longer and leave later, they don't do as well. And so that's what we're seeing here. So the number of young fledge really depends on the habitat you choose for your wintering habitat, because it affects your reproductive success quite a bit. So you're going to expect to see very strong selection on individuals to acquire those good habitats to winter in. This question is asking about the arbitrary contest resolution. Arbitrary resolution states the resident always wins. Why is the fitness greater in individuals occupying the territory than the intruders? As I mentioned a few minutes ago, a lot of times what happens is individuals that own the territory have greater benefit of the territory for a lot of different reasons. They know the resources that are there, they know the risks that are there, so the benefit to them is greater. The costs also sometimes are less. So if they've established relationships with neighboring territory owners, then the cost to defending that territory has gone down. Resident can have higher benefit and lower cost for a particular territory as opposed to the intruder coming in. Now, if an individual comes along that's more fit for that environment, will they defeat the occupying individual? So if a stronger individual that's a better fighter can come in, think of it this way, it can incur that cost. It could incur that cost and maybe beat up the resident. However, keep in mind with the arbitrary contest resolution hypothesis, the presumption is at the start of this hypothesis is that there isn't anything physically different about these two contestants. They go in and they say, I don't see that there's any body size differences. I don't see, anything that would indicate why one should win and one should lose. But wouldn't you know, it seems like the owner seems to always win. So under the arbitrary hypothesis, we're kind of presuming that they're equal in their ability, but in this case, it's the resident that tends to win. Then this is asking again about the arbitrary. Are there circumstances where this would actually take place? Here's the problem with actually showing and providing data on this. Now, the data from the butterflies seem to indicate this, but we also now have gone back and realized that there were some flaws to the experiment that introduced some biases that were not really understood at the time. What they found was that if they had a particular individual that was the owner and they caught that individual, and they found that it always wins, so they throw another individual in, and this one that's the owner always wins. But then they could switch it up and find that if we change the scenario and let the other individual be the owner, then it wins, which is telling us there's not anything intrinsic about that butterfly. It just happens to be circumstantial. If it's the owner, it wins, and if it's not, it loses. We do seem to see that. The problem that you have here with the arbitrary hypothesis is actually showing that there isn't some underlying difference between them, slight differences in their ability to fight a little bit longer, slightly different body sizes, different chemicals. There's so many different things that animals can use to assess one another that we're not privy to because we don't have the same sensory system that they do. So it's really hard to actually claim that something is arbitrary. We do think that it happens, but it's not something that's going to be very super easy to show because of that arbitrary nature and proving that it's actually arbitrary. This question is asking about the payoff asymmetry hypothesis. Is assumed that the primary factor that allows the owner to win is just time of tenure. So for payoff asymmetry, what you're looking at there is the fact that the individual, let's say you've got a resident and you've got an owner, and the owner has a bigger payoff. And so the bigger payoff to the owner, again, might be that it knows how to use these resources better. So it has a better way to navigate this particular territory that an intruder would have to learn. So this intruder would have to come in and incur a cost to use it just as good as the owner does. It also can be that the cost to defending it for the owner is a little less than the cost of trying to take it over for the intruder. The owner knows where the hiding spots are, the vantage points. There's all sorts of things that the owner knows about this territory that raises the benefits and reduces the cost to defend it. Those are the primary things. Could it be that there are underlying differences like resource availability? Well, again, if you're talking about an owner and an intruder fighting over a particular resource, that the resource availability probably isn't an issue because it's the same resource unless, let's say there's some phenotypic plasticity and now this owner can use this resource in a way that an intruder can't. Then that might actually be something that would be a possibility. This question is asking about age-related effects of territoriality. So it's asking why wouldn't the older organisms be weaker or not as quick or agile than the younger ones? They can be, obviously, a lot of times that is true, that younger individuals might have a little bit be more physically capable. However, what is happening here is you're looking at the defender is actually more persistent in that contest. So defenders are spending longer time defending with age. The idea is that individuals invest in different strategies in ways that will influence their fitness. Individuals that are young have a future reproductive value that's pretty high. So if they're going to live another 10 years and they have 10 more years of reproducing, then there's a good chance that they're not going to overinvest this year if it's going to cost them in future years ability to invest. So if I'm not going to be much willing to risk my life this year if I have 10 more years coming that I can reproduce. The idea with older individuals, as if they are not likely to have a whole lot more reproductive opportunities in the future, then withholding that effort this time is not as valuable. And so they're more likely to fight harder and use that resource when they're on later reproductive attempts later in life than they are earlier in life. So it kind of comes back to life history strategies and when do you invest and when do you sort of save your investment and when do you go ahead and spend your investment. And so the idea is later in life, we're more likely to spend that investment. This question is asking about the dear enemy hypothesis. The dear enemy hypothesis is one of the things that is saying having known familiar territory owners near you can decrease the cost of your defense. If you have individuals that you have been interacting with on nearby territories for a long time, you've gotten sort of to know each other, you know who they are. What they find is that there's two things that happen. If it's a familiar neighbor, I'm going to let it get pretty close to me without charging it, but if I don't know that individual, I'm going to charge it more often. And then the other part was how far they would chase it. So if a familiar individual came into my territory, I would chase it for a few centimeters, but not very far. But if that was an unfamiliar individual, I would chase it further. Having individuals in your surrounding territories that you're familiar with reduces the cost. So that's the idea of the deer enemy effect. They're your enemies because you're territorial and you don't want these neighboring individuals to encroach on your territory. But it's better to have individuals that you know next to you than unknown individuals. So this is asking for specific examples of the benefits of moving to a new habitat. Mostly the new benefit of dispersal would be moving to a habitat that has more resources on it. So usually when animals move to new areas through dispersal, it's usually to find energy, so food sources, sometimes water, sometimes nest sites. But usually there's some resource that they need that supplies that benefit. If they have the same energy resources where they are now, then they aren't not going to disperse. But if they need resources and the resources on the habitat they're sitting in currently are dwindling, then they're likely to disperse to a new area. This question asks, would migration still exist if Earth's angle was at 0 degrees? Had me thinking, is it an evolutionary adaptation to seasons? Absolutely. I think that most of migration is linked to season in some way. Not all seasonal migration perhaps is due to latitude. So it could be that water patterns and various like monsoon seasons and stuff like that can generate migration. And even a lot of those kinds of things can be correlated back to some of the larger climate patterns that have to do with latitudinal effects and that sort of thing. So the vast majority of them are going to be due to the fact that come spring, there's this huge excess of food in the temperate regions. So animals migrate up to that to take advantage of all the new, spring bloom and the spring insects and all of that, because it's just this huge resource that is there. And so most of that migration probably does have to do with climate differences that are related to latitudinal differences. This question is asking about European blackbirds and the conditional strategy that we have here. So what this one is remember what a conditional strategy is. So the difference between an alternative strategy and a conditional strategy. Alternative tactic is one that is genetic. So I might have a bird that has a genotype that migrates, and it always migrates. And then I have another bird that has a genotype that doesn't migrate, and it never migrates, and it can't switch back and forth. But a conditional strategy can switch back and forth. So an individual that migrates one year can not migrate the following year. And so the data here are primarily showing that in these European blackbirds, it is a conditional strategy, not an alternative tactic. It's not a genotypic difference, because what they're showing here is in A here, you're looking at individuals that were residents last year. If they were residents last year, what do they do this year? These individuals in the blue here are the ones that are residents this year. But look, some of the individuals that were residents last year actually migrated this year. And then the same thing over here. So some individuals were residents, they stayed residents, but there were some residents that migrated. And then the same can be true over here. These are the ones that migrated last year. Some of the ones that migrated last year also migrate this year, but then some of them are residents this year. So it's showing that the animals can switch back and forth in this, and that makes it a conditional strategy. This is asking about why aphids might prefer the larger leaves. Forget about female 2 and 3 for right now. If you were a lone female on a leaf of a different size, then if you picked a leaf size of 14, this is essentially how many offspring you could make, 138. If you were a lone female and you picked a slightly smaller leaf, you're going to make 95 offspring, and if you picked an even smaller one, 80. And the reason for that is that they suck juices out of the leaf, so they have these piercing mouth parts and they suck the juices out. And so individuals that find larger leaves, our larger leaves have more food in them, and so larger leaves have more nutrients. If you're a female and you pick a larger leaf, you get more food, and that also gives you a higher reproductive success. So they're always going to prefer the larger ones. The question in this one was, well, what if the larger ones are occupied? Well, if the larger one is occupied, basically you have two choices. You could be the first female here on the smaller leaf, or you can jump in with this female on the bigger leaf and be the second female. If we're going to do like an ideal free distribution model, all females should first pick the basal position on the leaves, so big leaves. And then once that fills up, then the next choice would probably be to go ahead and join. The second choice would be being the basal female here. And then the third choice would be a second female in one of these larger leaves. Larger leaves gives you more resources.